Welcome back everybody, Mr. Allen here. I'm going to go through some of the solutions for the permutation problem set 2. It looks like I focused on the questions that had numbers being created by digits with some sort of restrictions put on them. I do like these questions. They allow for a little bit more nuance, probably not the right word, but we'll move on anyways. How many 4-digit numbers can be made using 0 to 7? No repeats. So if you've seen some of the previous videos, I always like to set up with kind of my locations where I'm going to put my values in. This is 4 values I'm trying to put down. I want to create a 4-digit number. So the key here is the 4-digit number, that first value cannot be a 0. And so that means it's a 1, 2, 3, 4, 5, 6, or 7. So there are 7 possibilities there. Once I've established that value, I can't have any repeated digits, so whatever number I used is now out of the way. But I still will have 7 possibilities for the second digit because now the 0 is allowed back in. And then 2 digits have been used up. That leaves me with 6 more here and 5 more here. And if I multiply those out, I get 1470. How many 3-digit integers are there? So once again, just kind of getting set up. I'll put my 3 locations. 10s and 1s digit are different. Okay, so this is an interesting one. Because I'm starting, or because I want to establish the 10s and 1s digits are different, I'm going to start with the 10s digit. With a lot of these questions, it's best to start on kind of the most specific piece of information. We'll see that a little bit later. Here, though, on the first one, we had that first number was the one that mattered the most. So that first digit was the one that mattered the most because it couldn't be the 0. So I wanted to make sure I dealt with it right away. Here's my 10s, here's my 1s, here's my 100s. And so just kind of in any old number, 3-digit integers again, I basically got all 10 values available to me for that middle digit. Oh, sorry, I missed this fact here. You may repeat numbers. So all 10 values are available for that second digit. That means I have only 9 values available for my last digit because it can't match with the previous one. And because of the repeated numbers, the digit out front here really doesn't matter. As long as it's not that 0 again, I'm going to be fine. If I multiply those out, I should get 8, 10. We'll scroll up here. 4-digit numbers using 1 to 6 only once. Oh, restrictions down here though. Do not have a 3 available to me. I'm making a 4-digit number. Okay, so I can get 4 spots here. I won't use the 3. Well, that just means I have now 1, 2, 4, 5, 6. Yeah, I have 5 values available. And none of them are problematic in any way, so I should be able to just say 5 possibilities here. The 3 is still not available, and whatever number I use is not available, so these are the values available. Now, one thing to sort of note here, and I maybe should point it out again, this is not the number 3, right? What I'm doing is I'm writing down how many different possibilities are there here. So my first digit is a 1, a 2, a 4, a 5, or a 6. My second digit is one of those, but not the repeat. My third digit is one of those, but not either of the previous repeats, and so on. So you do have to kind of keep that straight when we're going through these. What we're writing on top are the number of possibilities. Ooh, ran out of room. In each case. So it's never the actual value that's being put in there. Okay, so looking at the next one, have a 1 in the third position. Now, with these questions, you should always note that each question is independent unless it refers to the previous one. So in this case, the 3 looks like it should be back in my group, or allowed again for my group. Again, 4-digit number, so just nice safe way to kind of get started here. I know that my third position is going to be a number 1. So in this position here, I'm going to have the 1. So I have the 1, and there's only one way to do that. So the 1 that I'm writing in here is the number of possibilities there. It happens to be the digit 1. I suppose I probably could have switched that up. After that, I now have 5 different values that are available to me. The 2, the 3, the 4, the 5, or the 6. Since I'm using each digit only once, I have 4 values available for the second position. Again, the 1 has been taken. Whatever was used in the first position has been taken as well. And then same argument, I have 3 left for that last position. And if I multiply those out, there are 60 different 4-digit numbers using only 1 through 6 with the 1 in the third position. 3 in the second position, 5 in the third, so basically same question. So actually what I can do is maybe this to make it a bit more clear. So again, when I listed them up here, what I was saying was those are the 5 values that are available to me. Down here, the only value that's available to me in position 2 is the number 3. The only value that's available to me in position 3 is the 5. And so there's only one possibility for each of those. Now that those 2 values have been established, I have 4 digits left for this first position. It could be a 1, a 2, a 4, or a 6. So those are the 4 values that are available to me. And then again, over here, the 3's been used, the 5's been used. One of the first 4 values has been used. One of this group of 4 has been used. And so whatever's left over is over here. And so that means there are only 12 digits that fit that. And with something like this, we could actually list them off. So we said we could have a 1 in the first position. We would then have a 3 and a 5. And we could have a 2 available in the last position. We could have the 1 in the first position, followed by the 3, 5, and the 4 in the last position. And we could have the 6 in the last position. We could have the 2 at the start, followed by the 3, 5, and the 1 at the end, and so on. So with only 12 possibilities there, we could actually have done that, and if I planned ahead a little bit better, I would have had them available just to show.